Hello everyone, this video is about parallelograms. The first part is sides and angles of parallelograms, and the second part of the video is about the diagonals of parallelograms, these two segments. We will talk about it later. So we have four different statements if PQRS is a parallelogram. Let's see the properties that we have. The first one is opposite sides are congruent. This means opposite sides are PQ. Let's put one line on it and then SR and PS and QR. So we know these measures are going to be the same if we have a parallelogram. The second property is opposite angles are congruent. So let's put that one. Opposite angles like P and R or Q and S are going to be congruent. The third property that we have, the consecutive angles are supplementary. So the consecutive angles are these ones. Let me choose another color here. Okay. This one, P and S. These two angles are consecutive because they're right by each other, or P and Q, or Q and R, or S and R. The measure of these, the ones that has one symbol and two symbols, their sums are 180 degrees because they're supplementary. The last property is if one of these angles, one of these are 90 degrees, all of them are going to be 90 degrees. Then we are going to have a square or a rectangle. Let's see the first example. If ABCD is a parallelogram, now let's look at the sides and angles we have. Remember, opposite sides are the same, like these two, and opposite angles are the same. If we have same quantities, we write them equal to each other. 2, 8, and 34. These are the same. Divide by 2. So we would get A equals 17. This is not just the one variable that we need to figure out. We also need to figure out B, 8B, and 112 are opposite angles. And they must be the same because of the second property, I guess. Let me see. Yeah, the second property. Opposite angles are congruent. So divide by 8. You would get 14. B equals 14. So this part of the lesson is about diagonals of parallelograms. We have two properties. The first one, you see these segments, they cut each other in half. They bisect each other. Like AC cuts DB in half, so we can put the same symbols on DP. Sorry about that. On DP and BP. And we can do the same thing because this segment is going to cut AC in half. AP and PC are going to be the same. This is the first property. They are always the same. But remember, the green ones and orange ones are not equal to each other. Only the green parts are the same, orange parts are the same. The second property says when you draw one bisector, when you draw one of the bisectors, it cuts the parallelogram in half. Like take this one for instance. Because of this, the triangle on the left side is going to be the same as the triangle on the right side. Or segment DB cuts the parallelogram in two equal triangles. That's what it says right here. So let's see the example. Find the value of x and y in parallelogram ABCD. Remember, the diagonals bisect each other. So AE and EC are the same. One part is 4y, the other one is 18. These must be the same. So divide by 4, y equals 4.5. Now, DE is 1/2 of DB. EB is the second half. So they are congruent. 6x and 24 are the same. Divide by 6, we will get x equals 4. Now let's have some example questions about measures of segments or angles of triangles in parallelograms. Before that, I will have two reminders. The first one is both of these are going to be about special triangles. The first one is about the relationship between the sides of 30, 60, and 90 degrees right triangle. The second one is going to be about 45, 45, 90 degrees triangle. 45 degrees, 45 degrees, 90. So, assume that the side opposite 30 degrees, which is right here, is A units. Let's say it's A units. So in this case, the side opposite 90 degrees, the hypotenuse is going to be double. So if opposite 30 degrees is A, opposite 90 degrees is 2A. And the side across from 60 degrees, the one on the left side, this leg here, is whatever that is times radical 3. So it was A, we are going to say A times radical 3 or A radical 3. So A can be any number for the other two sides across from 30 degrees. Whatever number we have, we are going to times it by 2 for the hypotenuse, and we are going to times it by radical 3 for the side that is across from 60 degrees. And the second special triangle is 45, 45, 90 degrees. So in this one, if the legs are A units, we know they are going to be the same because they both are opposite 45 degrees. So if this side is A, the other one is going to be the same because the angles opposite the sides are the same. If these are A units long, the hypotenuse is going to be that side times radical 2. So because we are going to use these ones for the questions. Okay, let's get started. The first triangle. Right here, we have 30, 90. The missing angle is going to be 60 degrees. You can figure it out by subtracting these two angles, 30 and 90, from 180 degrees. In that case, we get 60 degrees for the angle at the top. Now, the sides opposite 30 degrees is 10 units. Let's remember what it was. If it is A, we times it by 2 to get the hypotenuse. A to A. So if this one is 10, the side opposite 90 degrees, the hypotenuse is 2 times 10, which is 20. We don't need that side, by the way, but it's just, we figured it out. The second one, this is all about finding the value of x's and y's. Right here. So the side y is opposite 60 degrees. Let's remember the relationship. If opposite 30 degrees is A, we time it by radical 3 to get the side opposite 60 degrees. To get y, it is opposite 60 degrees. We times whatever we have across from 30 degrees. We have 10, we time it by radical 3. This is the length of y. So x is easier than this because it is part of the diagonal. 10 and 3x is cut by this diagonal. And it cuts it in half. That means the measure of 10 and 3x are congruent. So 3x is equal to 10. To figure out 1x, we divide each side by 3, and then we get 3.3 repeating. Here's the measure of x, and this is the measure of y. Now, the second example, we have, as you see, we have two angles congruent, and one of the angles in this triangle is 90 degrees. So subtract 90 from 180, we get 90. Divide it by 2 because these angles are the same. One of them is going to be 45 degrees. So the one on the left is 45. The one on the right, which is 3x, is also 45. So that means 1x is going to be 15 degrees. About the y, let's figure that one out. So if this part of the diagonal is 2y, this right here is going to be the same. It's going to be 2y. Because remember, diagonals bisect each other. So here we have 2y. Now I'm going to draw this triangle right here. The angle at the top is 45 degrees. Sorry, 90 degrees. The corner angles are 45 degrees. Legs are 12. So if opposite 45 degrees is 12, across from this angle, the side is going to be the same. Because the triangle is isosceles right triangle, the sides are the same. Now, let's remember what we had. When we have an isosceles right triangle, the legs are 8 units, and then we time it by radical 2 to get the hypotenuse. So look at here, we have the missing side is the hypotenuse, the legs are given, that means we time it by radical 2 to find what the hypotenuse is. Remember, the hypotenuse was equal to 2y, right? This one was given 2y. We figured out that this one is going to be 2y as well, which is this length. So it is 2y and 12 radical 2 at the same time. That means they are equal. So we need to figure out what 1y is. So we divide each side by 2. Y would be 6 radical 2. Now the last example, we have a parallelogram cut by the diagonals. Okay, let's see. Here we have 4 units. The other half of the diagonal is going to be the same. That's going to be 4. So right here we have 4. So second thing that we need to know, if this is y, right here, that one is y. Now, another thing, we have the side in the bottom, which is 17. Remember the first property about the parallelograms, opposite sides have the same measure. So this one is going to be 17. Now, I'm going to take this triangle and then use Pythagorean Theorem. Let's draw that one to here. 90 degrees, hypotenuse is 17. One of the legs is x, the other leg here is 4 plus 4. They're right by each other, added together, which is 8. So the Pythagorean theorem tells me that if we square the legs, x squared and 8 squared, their sum would be equal to the hypotenuse squared. So x squared stays the same. 8 squared is 64. 17 squared is 289. Yeah. So we subtract 64 on each side. X squared would be equal to 225. So we need to get rid of this square by doing its opposite, which is square root. So x would be radical 225. That's a perfect square. X would be 15. Now the only thing that is left is figuring out what y is. So for that, we will need to use this right triangle here. Now we know what x is equal to. It is 15. So I can put 15 for that. I'm going to take that triangle, draw it up here. Right angle, left side was x, or 15. This side is 4. This side, the hypotenuse, is y. Now if we do Pythagorean theorem for this triangle, what we have is 15 squared, square the legs, add them together, it equals hypotenuse squared. 15 squared is 225, 4 squared is 16, y squared stays the same. So left hand side, if we add the numbers up, we have 241. Right side stays the same, gets rid of the square by doing its opposite. So y would be equal to square root of 241. It's about 15. It's more than 15, less than 16. I don't need the exact value of that. So that's what y is equal to. This one is the last example of the lesson. It's about finding the coordinates of the intersection of diagonals of a parallelogram. So we have given vertices. Let's draw a random parallelogram. It doesn't need to be on the coordinate plane. Point A is 3, 6, but we need to follow this pattern. We cannot skip any points. The next point, it doesn't matter which way you go, 5, 8, but you need to continue going the same way. C is 3, negative 2, and then point D is 1, negative 4. So, as you know, this is going to have two different diagonals. The first one is going to be like this. The second one is going to be like that. And then they're going to meet at right here. And this question is all about finding the first and second number of this coordinate. Okay, let's get started. First thing, let's start with the orange segment, okay? So what we need to do is we need to write its equation. Once we get the equation of this line and that one, we can set them up equal to each other and then find the common solution to both of them. Those are going to give us the x and y values. So to write down the coordinates, we will use slope. We cannot use slope-intercept form. We can figure out their slopes by using the endpoints. You know, y2 minus y1 divided by x2 minus x1 is the formula of slope. We can use that one, but we don't know what the y-intercept of this segment. It's not given, but we have 2 points on the segment. We can use one of them and the slope to write down the slope, point slope form. So let's remember what it was. Point slope form is y minus y1 equals m times, m is the slope, x is the variable, x1 is the x coordinate of the point. And on the left hand side, y is a variable, y1 is y coordinate of a point on the line. And let's remember the slope formula. Sorry about that. The slope formula is, or m equals y2 minus y1 divided by x2 minus x1. Now we can get started. The orange segment. The equation of the orange segment is going to be y minus y1. So y1 is going to be either this point, that coordinate, or this coordinate. It can be y coordinates of any of these points, D or B, because they are both on the orange line. But I'm going to use this point because they are positive numbers. It's going to be easier for me to set up the equation. So y coordinates of point B is 8, y minus 8 equals m times, I'm not going to write it right away, x minus x1. x1 is 5. So the only thing that we need to figure out is the slope of the orange line. So it says y2 minus y1, right? So here are the points on the orange line. Subtract the y values. 8 minus negative 4, it becomes positive 4. That means at the top we have 12. Divided by 5 minus 1 is 4. So the slope of the orange line is 3. I can write it up here. Now let's move on to the purple line. Y minus, again, I'm going to do the same thing. I'm going to use 3 and 6 for x1 and y1. Let's write the equation. So we cannot write the equation of this purple segment by using point slope form, but I want to try and then explain why we cannot write it. So it would be y minus y1, right? So let's figure out what y1 is. It is this point. We could use negative 2, but I don't want to deal with negative numbers. So I'm going to do y minus 6 equals the slope. We don't know what that is yet. X minus x1 is right here, which is 3. Sorry, 3. So let's find the slope right here. The slope of the purple line is 6 minus negative 2. Negative 2 becomes positive. 6 plus 2 is 8. In the bottom, what we have is 3 minus 3, which is 0. So the slope is undefined. If it is undefined, we cannot write anything undefined over here. There's no such thing. So we cannot write the equation using any form that has slope in it because the slope is undefined. So instead, we are going to write it in the standard form, which means, so let's give a shortcut. Look at the x-coordinates of these points. Both of them are 3. That means whatever y equals, x is always 3. So if x is always 3, the equation of the purple line is going to be x equals positive 3. So I can explain it over here using this coordinate plane. Point A is 3, 6, right? Over 3 up 6, it's going to be somewhere about here. And then the second one is over 3 down 2, it's like here. So any segment passes through these 2 points is going to be like this. And then the equation of this segment, this line, is x equals 3. That's why if you have 2 numbers for x coordinates, the equation of it is going to be x equals that number. Or if you have anything like, let me give another example. Let's say you have these points and 5, 6. As you see, the y value of these 2 coordinates are the same. So the equation of any segment passes through these 2 points would be y equals 6. Okay, let's come back to the question. Now we have the equation of the orange and purple segments. So we know what these equations are. One of them is x equals 3. The other one is this longer one. So this one here tells me something. This says x coordinate of this point is 3. Because if x equals 3 on the purple line, it must be valid for the orange line because they are meeting at that yellow point. That means take the orange segment, orange equation, and then write x equals 3 wherever you see x. So let's get started. Y minus 8 equals 3 times x minus 5. Instead of x, we are going to write 3 subtract 5. On the right hand side, we have 3 times 3 minus 5 is negative 2. Left hand side is y minus 8. Right hand side becomes negative 6. Left side stays the same. We add 8 to each side. So y would be positive 2. We knew what x was. Now we know what y is. So they're meeting at 0.32 for this question. That's all for this lesson. If you have any other question, please comment below. And I will see you in another video.